Video is about finding eigenvalues and eigenvectors of 3 by 3 matrix. Now now we're going to do this through objectives. We have got 5 objectives to cover. So let's start with the first one, which is review. Now we're going to review 2 items. The first one is parallel vectors. Parallel vectors. Okay, now if I take any vector v multiplied by scalar, I will get another vector which is parallel to v. Okay, so v prime parallel to v when lambda is a scalar. Now let's do this using a very simple vector in 2-dimensional vectors. So I have vector 1 1 here. So this is vector 1 1. Take vector 1 1 multiplied by 2 and you make vector 2 2. Vector 2 2 will be somewhere here on the same line. Now, of course, if lambda is positive, the 2 vectors are parallel in the same direction. If lambda is negative, the 2 vectors are parallel in opposite direction. Now, let's put here the vector symbol of the vectors. Good. Now, let's go to the second point in the review. Take matrix A multiplied by certain vector v. Now here, just to make it simple, let's talk about a 3 by 3 A matrix, and v, it's a 3 by 1 column vector. Now if you multiply this v by A, by matrix A, you are transforming, you will obtain another vector. Let's call it v prime. Okay, so multiplying v by matrix A, you are making a transformation. You will obtain another vector, but this new vector, let's call it v prime, it can be, there are 2 possibilities. Either it is parallel, I'm going to use this symbol for parallel. It's either parallel to v, so this v prime, the result of the multiplication, it's either parallel to v or not parallel to v. We are interested in this situation here, when the result v prime is parallel. So if v prime is parallel to v, it means that I can write this v prime equal a certain scalar v. And then we go to our equation here, A v equal lambda v. Okay. Now in this situation, if we can find these v's and lambdas, v is called the eigenvector of matrix A, and the lambda is called the eigenvalue of, again, matrix A. So this is about the definition. This is a quick definition of the eigenvalues, eigenvectors. Now that we have defined what is an eigenvalue, eigenvector, let's go to objective number 2 and write the equation again and put the conditions. So the last equation we saw, it's to solve A v is equal to lambda v. Now when we look at this equation, v equal to 0, it's an obvious solution. This is the 0 vector, yeah? It's an obvious solution, but we don't want it, not want the solution. We want a solution, so we want to find v that is not equal to the 0 vector. Good. Now looking at the equation, we can see that on the left side it's a matrix multiplied by V. On the other side it's a scalar multiplied by V. So let's make some transformation so that both sides look the same. Okay, to do this now, remember, now A is a 3 by 3 and V it's a 3 by 1. So let's consider the identity matrix I3, which is the identity the 3 by 3 identity matrix, and that is written 1 0 0 0 0 1 and so on. If you multiply this I3 by any vector of the form 3 1, you will obtain the same vector because this is an identity. You can try it as an example. This is very well known results. So we are going to go to our equation, the one we want to solve. A V on this side is equal to lambda V. We want to write V as I3V. Now, when we do this, it makes more sense. The equation is a matrix multiplied by V, and then this is a matrix lambda I3 by V. It makes more sense. It's more of an equation. Now, lambda, let's develop this lambda I3. This is lambda multiplied by and if you do this, you will get a matrix, of course. So lambda I3, it's a 3 by 3 matrix, V, and so on. Good. Now let's write our equation now into standard form, meaning one side equal to 0, and it gives you lambda I3V equal to the 0 vector, remember. So we just subtract this term from both sides and to obtain our equation. The next obvious thing to do is to factor the V out and write our equation like so. This is a homogeneous system of equation. V equal to 0, as we said above, is a solution. We want V not equal to 0, and the only possibility is when the determinant of A minus lambda I3 is equal to 0. If this condition is satisfied, it is possible to find solution V's not equal to 0. Now, in objective number 3, we are going to determine what we call the characteristic equation, starting from the determinant of this matrix here. So, A, matrix A, minus lambda I3, it's 1 0 0 0 1 0 and then 0 0 1. Now when I do this, it's going to give me negative 1 minus lambda times 1, or I think it's better if we just multiply this by lambda here, put them inside to avoid mistakes, and then we subtract straight away. So negative 1 minus lambda, two minus 0, negative 1 minus 0, two minus 0, and then 3 minus lambda here, and then 1. The last row will be minus negative 1, 2, and minus 1 minus lambda. So the next step is to determine the matrix of this, which is this. Now let's call it B. Let's call it matrix B, all this. So the determinant of B is equal. There are many ways to do the determinant. I do it by using this row and then the corresponding 2 by 2 matrices. So I will start with this element, -1 minus lambda, multiply by. So this is the element I am using. Take this row out, take this column out, and I am left with a 2 by 2 here. And I'm going to put it here. Now I go to the second row. When I go to the second row, remember when you do this, it's a plus, minus, plus, and then you continue. So this one here, I need the -2. Take this column out, take this row out, you are left with this and this. 2 negative 1 and 1 minus lambda. When you go to the third one, it's a plus with a minus 1, and then, so when you do this, take this out, take the row containing this term, take the column containing, and then you are left with 2 minus 1 here, 3 minus lambda, and then 2. Good. Now these are 2 by 2 matrices, which we know how to do here. The determinant of 2 by 2 matrix A, B, C, D, it's given by, you multiply this 2 minus B, C. So let's go and apply it here. So the determinant is equal to -1 negative lambda. All right, now multiply -2. Now I think it's better if we use a square bracket to avoid any confusion. So 2 -1 minus lambda, and then -1 plus 1, and then this -1 here, let's go down to have more space. 4 minus this product, it becomes plus 3 minus lambda. Check it. Continue simplifying. So I have -1 minus lambda. Now let's do this here. Let's do it mentally. Yeah. So let's start with the highest power. That gives me lambda 2. And then the constant term, it's a 3 multiplied by -1. That gives me -3, -2, -5 here. And then the terms with lambda, there is a plus lambda. When you do this with this plus lambda, when you do this with this -3 lambda, that gives me -2 lambda, or -2 lambda. Now let's go to this one here. So I have -2. Now inside I have the 2 by minus lambda, -2 lambda. 2 by -1, -2 plus 1, that gives me -1. And then the last one, 7 minus lambda. Good. I'm going to distribute this on here and here. So I will have -1 and then multiplied by the whole thing, by the whole bracket. And then minus lambda multiplied by lambda 2 -2 lambda -5. Now let's start simplifying. Plus 4 lambda here. Plus 2. -7. I'm doing this now. -7 and then plus lambda. Good. Okay. Now 2 lambda here. I think we can start simplifying straight away now. Now let's do this and this first. So very quickly, negative lambda 2 plus 2 lambda plus 5. And then here minus lambda 3. I'm doing this now. Plus 2 lambda 2 plus 5 lambda plus 4 lambda. Then 2 minus 7 minus 5. And this lambda with this 4 lambda 5. Let's put it 5 straight away. Now we start grouping. I have the highest power, only 1 with lambda 3. Good. I have negative lambda 2 plus lambda 2, that gives me plus lambda 2. 2 lambda and 5 lambda and 5 lambda, that gives me 12 lambda. Plus 5, negative 5, 0. This is my determinant. It looks much smaller and less intimidating than at the beginning. Good. So this is the determinant of B, and remember what we want to do. The determinant equal to 0, and this is what we call the characteristic equation. Characteristic equation, which we need to solve. So we need to solve this equation, and the first thing we need to do, let's factor negative lambda out. That gives me lambda 2 minus lambda minus 12 equal to 0. Now let's check this. Minus lambda 3 plus lambda 2 plus 12 lambda. Now minus lambda, let's factor the terms within the bracket, all these ones here. I need two numbers. When I multiply them, they give me negative 12. When I add them, they give me minus 1. So it looks like minus 4 and the 3. The product, negative 12. And when you add the minus 1, yeah, it makes sense. So lambda minus 4, lambda plus 3. Let's check. Lambda 2. 4 lambda, 3 lambda, 1, and then minus 12. Good. And the solutions are lambda equal to 0. And then this lambda minus 4 equal to 0 gives me lambda equal to 4. The second solution. And then the equation lambda plus 3 equal to 0 gives me lambda equal negative 3. And these are my eigenvalues. Let's put them here. So these are the lambda values, the eigenvalues. And yeah, let's call them lambda 1 equal negative 3. Lambda 2 equal to 0. Lambda 3 equal to 4. So these are the eigenvalues, 3 of them. Good. We now go to objective number 4, which is finding the eigenvectors. Now remember the equation we have to solve. It's A minus lambda I3 V equal to 0. And then this, we found above that it is given by this matrix. So now we start the calculation, and then we start with the first eigenvalue, lambda 1 equal negative 3. So for lambda 1 equal negative 3, this matrix here becomes 1 minus the 2. So what I will do, I will substitute the value of lambda 1 here in the diagonal. So that will give me, for example, negative 1 minus 3, that give me 2, and then 2 minus 1, and so on. 2 minus 1. And then the second row now, 2. 3 minus 3 is 6. and then 1. The last row is negative 1, 2, and 2 here, minus 1 plus 3. Good. So this is the matrix. Now let V, the vector we're looking for, it's a 3 by 1. So let's call the component x1, 2, and 3. Now when you put it here, x1, x2, x3 is equal to 0. The vector 0, 3 components. Good. Now the idea is to find x1, x2, and 3, and you can do it either using the equations or the matrices. I prefer the matrices. You are dealing only with numbers. So in augmented matrix form, this will be written as 2, 6, 1 here, and then minus negative 1, 2, 2. Let's put a line to separate the 0. In fact, we don't have to put the zeros because they are not going to change when we apply the row operations. Good. R1, so this is R1, this is R2, and this is R3. Now the first thing we are going to do is to keep row number 1 as it is. The zeros here. Now row number 2, we are going to do to replace it by row number 2 minus R1. So we do this minus this, because 2 minus 2 gives me 0. Remember, just something, we need to have 0 here, here, and here. This is, we reduce it to row echelon form. So we need R2 minus R1, that gives me 2 minus 2, 0. 6 minus 2, 4. 1 minus minus 1 gives me 2. Z0, they will not change. Now the last row, this one here, I'm going to multiply it by 2 to have minus 2 here, and then add it to the first one. So the last row is 2R3 plus R number 1, and it will give me 0. Remember, 2R3, you multiply, that gives you minus 2, 2 plus 2, 0. This gives you 4 plus 2, 6. And then 2, 4, minus 1, 3, and then 0 here. Good. Now the next thing we are going to do is we need 0 here. So it looks like we cannot use, remember, we cannot use row number 1 because it has got 2 here. It will bring the 2 here. So the only way is to use row number 2, which is not, it doesn't look good. Let's divide it by 2. So we divide this row by 2. Okay. So let's call this R1, R2, and R3. So R1 unchanged to 2 minus 1. So R2 by 1/2, multiplied by 1/2. 0. So you multiply all this by 1/2. 0, 2, 1. And 0 here. And R3, it's unchanged for now. 0, 6, 3, 0. Now I am going by steps without jumping anything so that you can follow it later on. Now we can have our 0 here by multiplying this by 3 and then subtracting. So the next thing we're going to do is to do the following. Keep R1. Now keep R2, of course, again, 2, 1, and 0. And now here we're going to put R3 minus 3R2. Why minus 3? Because look, 6, I need minus 6. So the only way is to multiply this by negative 3, so 6 minus 6 give me 0. Good, let's start. So this is 0 and this is 0, no change, it will give me 0. 6 minus 3 times 2 is 0. 3 minus 3 times 1, 0. And this gives me 0. So we are now ready to solve. We rewrite the system of equation again, 0, 2, 1 here, 0, 0, 0. And remember, we have the x1, x2, and x3 components. And the constant are all zeros. Good. It seems that the last row is the easy one to solve. So this reads like 0 times x1 plus 0 times x2 plus 0 times x3 equal to 0. Now forget about the 0 x1, forget about 0 x2. We simplify, and then we end up with this. And this equation tells me that x3 can be any real number. Let's call it t. T is any real number. Good. So, one component done. Let's go to this equation here. 0 times x1, 2x2 plus x3 equal to 0. So, 2x2 plus x3. 2x2 plus x3 equal to 0. 0, that gives me x2 equal negative half of x3. It means negative of t. Don't forget, x3 equal to t. Now we go here to the first equation. The first equation tells me that 2x1 plus 2x2 minus x3 equal to 0. Now I replace, so that gives me 2x1. I substitute 2x2. When I go here, that gives me minus t minus x3. x3 is t, so this is also minus t. And when I solve, this gives me x1 equal to t. That's it. We have the three components. And conclusion, when lambda equal lambda 1 equal negative 3, the eigenvector v1 is equal to, let's write it like this. A real number t, any real number, multiplied by the component x1, x2, x3. So x1, we put 1 here, negative half, and then 1. Okay? When you multiply by this, it will give you x1 equal to t, x2 multiply half t, and then x3 is equal to t. So this is the results for the first eigenvector corresponding to the first eigenvalue lambda 1 equal negative 3. Now let's go and find the eigenvalue, the eigenvector corresponding to the eigenvalue lambda 2 equal to 0. So again, the same equation to solve, and A minus delta I3 is this matrix here. So let's put delta equal to 0, lambda equal to 0, negative 1, 2, minus 1 here, 2, 3, and 1 here, negative 1, 2, and minus 1 here, the augmented matrix, and here we have got the zeros. Good. So we try to make zeros here, here, and here. Now it goes like we keep R1, the first row, as it is. Now the second row, we're going to replace it by R2 plus 2R1. Yeah, if we have a 2 here, so we need to multiply this by minus 2, so that 2 plus minus 2 gives me 0 here, and 7 here, R2 plus 2 R1 and negative 1 here. Now the third row, it's we just replace it by R3 minus R1. Now they are they are similar, so they will give us 0 everywhere here, and then 0 here, and then 0 here, and I think it's done. The reduction is done now. All what we are going to do is to rewrite the system of equation. So the system equation is written like this: 0, 7, negative 1, 0, 0, multiply by the component of the vector. We call them x1, x2, x3, and this should be give me the vector 0. Good. So let's start with the last row. Zeros everywhere. So 0x1 plus 0x2 plus 0x3 equal to 0. Yeah, we multiply this row by this, and it's equal to 0 here. Now let's simplify these zeros, and then let's solve the equation 0x3 equal to 0. That means that x3 can be any real number. If you put any real number, you multiply it by 0, it gives you 0. So t is any real number. Good. Now let's go to the second equation. The second equation tells me that 0 times x1. So to obtain the second equation, I multiply this row by this column. 0x1 plus 7x2 minus x3 equal to 0. Equal to 0. Now I substitute x3 by t here, and that gives me, and then I solve, and that gives me 1 over 7t. That's for x2. This is x3. Now for x1, I use the first row by this column, the first equation if you want. So I write it down first. Negative x1. Okay, I am multiplying this row by the column minus x1 plus 2x2 minus x3 plus 2x2 minus x3 equal to 0. And then we substitute. Now we're looking for this, so that gives me minus x1 equal minus 2x2, which is 1 over 7t, and then plus x3, that's a t, and then when I simplify here, that will give me a t, 7t over t. That's negative 2 plus 7. That's 5 over 7 minus 5 over 7t. Good. So when lambda equal 2 to 0, the eigenvector, let's call it v2, is equal to a real number, any real number t, multiply. Now let's put the component. x1 is minus 5 over 7t, so we put here minus 5 over 7. x2, it's 1 over 7, and x3, it's 1. That's the eigenvector corresponding to lambda equal to 0. We now go to the third eigenvalue, and again try solve this system of equation. So with this matrix here equal to this, let's substitute the lambdas, the lambda value, and that will give me minus 5 or negative 5. So again, put the 4 here, here, and here, and then just rewrite the matrix. Negative 1, and then 2, negative 1 here, and then 1 here, negative 1, 2, and negative 5. Good. Now again, we create the augmented matrix, 5, 2, negative 1, vertical line, the zeros here, 2, negative 1, 1, negative 1, 2, and negative 5. And remember what we need to do, create zeros here and here. Now there is one row which has got a negative 1 here, so maybe the first step, it's good to interchange these two rows. So this one will go at the top, and the first one will go at the bottom. 2 minus 1. Now the second one unchanged. Our zeros here. Good. Now the next thing we are going to do is to create 0 here and 1 here. So we do this by doing the following. Now we keep R1 as it is. Now we go to R2 and then we add to it twice R1. So R1 as it is. R2 becomes R2 plus 2R1. That will give me 0, 3, and then negative 9. Okay, so 2 plus 2 times minus 1, 0. Minus 1 plus 2 times 2, 4, that gives me 3. And then 1 plus 2 times minus 5, minus 9. The last one, I need an R3. An R3 because I've got a minus 5 here. So I need to multiply this by minus 5 to give me plus 5. So that will give me minus 5 R1 here. And then when I do my calculation, 0, negative 8, 24, of course the zeros here. Now, row number 1 is good, row number 2 is okay. What we need now, we need the 0 here. Okay, so negative 1. Hang on. So this is row number 1. Okay, so we said row number 1 unchanged, row number 2 unchanged, row number 3 we divided by 8, or we multiplied by 1 over 8, 0, 0, 0. Now again we keep row number 1, keep it. Zeros. Row number 2 we keep it. And now for row number 3, what we will do, we will add row number 3 times row number 3 plus row number 2. Yeah, imagine when you multiply the negative 1 by 3, it gives you negative 3 plus 3 is 0. So that will be 0, 0, 0, and then the zeros here. Now we start solving. That's looks a little bit out of size. Good. We start solving. So we go the last row. 0x1 plus 0x2 plus 0x3. We keep only one variable. 0x3 equal to 0. That means x3 can be any real number. Remember, if you put a real number here, you multiply it by 0, it gives you 0. Now the second equation, we go to this row now. The second row gives me 0x1, so that's 0, 3x2 minus 9x3 equal to 0. And then when I substitute x3 by t, that gives me x2 equal 3t. So second one, the first equation, go back to the first equation, that gives you minus x1 plus 2x2 minus 5x3 equal to 0. Substitute x2 by 3t here, substitute x3 by t here. When you do all this and you solve, you will get x1 equal to t. This you will have to do it, otherwise it's going to take a little bit of time. So when lambda is equal to lambda 3 is equal to 4, the vector, the eigenvector v3 equal, again we can keep the t outside, 1, 3, and then 1 here. So we have found the 3 eigenvalues. the three eigenvectors. Now we are going to put all these together, and we are going to verify that these are eigenvalues and eigenvectors, the corresponding eigenvectors. Okay, so here we put everything together, the lambda 1 equal minus 3 v1 and so on. So now what we are going to do, this is objective number 5, check our results. Good. Now remember, the main equation, the starting equation was A V equal lambda V, and this is what we have to check right now. Good. Let's start with the let's put A here first. So A equal negative 1, 2, negative 1, and then 2, 3, 1, and then negative 1, 2, negative 1. Now let's do lambda 1 and v1. Yeah, lambda 1 and v1, of course. So v1, what is v1? Now v1, we're going to write it with the t inside, so we multiply everything. Yeah, so we write it like this. We write it like this: t minus half t and then t. Okay, when you multiply the t here in the component. Good. And we are going to prove that this is equal to lambda v. So we multiply. Now remember how to multiply this: row by this column, and it's going to give me, again, I'm going to put all the details. So that's minus 1 with a t, that gives me a minus t here. Now, and then the 2 with minus half t, that gives me a minus t, and then the minus t with the t here, that gives me minus t. I think there is, yeah, we continue. Yeah, we are multiplying this row by this column. It gives me this. We will simplify in a few minutes. Now let's do the second row, this row by this column. So 2t minus 3 halves, 3 over 2t, and then plus t. And then the last row, this row here, by the same column, that gives me minus t, and then minus t here. Now when I put all this together, it gives me negative 3t, and then 3t minus, okay, so this gives me 3, yeah, 3 over 2t, and then the last one, negative 3t, and this can be written as, let's take the negative 3 outside. It will be written 3 minus 1 half t, and then t. So what do we have? We have A. This is my A. This is my V1 is equal to what? My lambda 1 by V1. This is V1 and this is V1 here. So satisfied. So we checked lambda 1 and V1. Let's go to lambda 2, and lambda 2 equal to 0 and V2. Yeah, we continue with lambda 2 and V2. So this is a eigenvalue vector number 2, and this is A. So this is A again. We are multiplying by V2. This is V2. And then let's go for the calculation. Good. So a negative 1 by negative 5 over 7, that gives me 5 over 7t. And then 2 by 1 over 7, 2 over 7, plus 2 over 7t. And then negative 1 by t minus t. Again, we will simplify this in a few minutes. Now let's do this row by this column. So minus 10 over 7t, and then plus 3 over 7t, and then plus t, plus, this is a plus here, plus t. Okay, good. And then the last row with the column, with the same column, minus 5, so it's plus of 5 over 7t, and then plus 2 over 7t, and then minus t. So here are all the calculations. Now we start simplifying. 5 plus 2, 7, 7 over 7t, t minus t, 0. Then here the fractions first, negative 10, 3, 7, minus 7 over 7 minus 1 plus 1, 0. And then here 5 over 7 and 2 over 7, that's 7 over 7, which gives me 1 t minus t, 0. And of course this can be written as 0, which is the eigenvalue. The second eigenvalue is 0, multiplied by any vector, and in particular 5 over 7t, 1 over 7t, and t, which is our eigenvector. So again, A multiplied by v2 equal lambda, which is 0 v2, satisfied. We now go and check the last one, lambda 3 equal to 4 and v3. So here is A, and this is v3. Let's do the multiplication. Here it's quite simple, there are no fractions. Negative t plus 6t minus t, that's 4t. Then 2 times t plus 3 times 3, 9, plus this, that gives me 12t. The last one, minus t plus 6 minus t, that gives me 4t. And this, if I take the 4 out, if I factor the 4 out, that gives me t, 3t and t, and again A times v4, the matrix A, sorry, by v3 equal the lambda, which is 4, times v3, which is the eigenvector number 3. Now, I hope that you have followed all this. Now, this video gave you both concept, meaning, and the skills to calculate all these eigenvalues and eigenvectors. The last part, which is verifying, it was done for the purpose of really understanding what are the eigenvalues and the eigenvectors and what are we doing. I hope this has been useful.